Okay, so what we're going to do today is you're going to have a worksheet where all of the different methods are together. So we just need to talk about the three methods. So what's one of the methods? Starts with an F. Factoring. So factoring, one of the things we need to do to be able to recognize whether we can factor it is we need to put it in standard form. And then what you'd have to do is to check to see if you can factor it. What's a pro for factoring? Positive. It doesn't take forever, so on the
mental math.
It can be easy, right? Can be easy. So what's a con? So this is standard form. Ax squared plus bx plus c is 0. So if your a is greater than 0, then when you multiply a times c, it could be a really big number. So it might be hard to find the two factors. What's another method? Quadratic formula. So again, we want to get it in standard form. And we would want to use it if what?
We have it in quadratic formula.
When would we want to use the quadratic formula? If it doesn't factor. Very good, Dexter. So use if equation doesn't factor. So what's a pro? What's a positive to that? Oh. What's a positive for the quadratic formula? I actually like it will always work.
Oh, there you go.
We can use it for any quadratic equation. So that's a positive, is it will always work.
Wait, sorry. On the test, are you going to ask us to use all three of them?
So on the test, there'll be two different parts. There'll be parts like today, your homework assignment, you're going to choose the method. So there's going to be some where you have to choose, and then there's going to be some like, say, solve by square root, solve by factoring, solve by quadratic formula. So what's a con for the quadratic formula?
Too easy.
So it takes a long time because there's so many steps. So that means there's a lot of steps to make mistakes. So we don't want to use the quadratic formula unless it doesn't factor, or we can use square roots. Because of this, when I give you the test, you have used the quadratic formula most recently, so your tendency may be to do that. But you're not going to have enough time if you try to do every single one of those with the quadratic formula. You're going to be stretched for time on taking your test. And then there's a lot of places to make mistakes. You don't want to do that. So what's the third method? Square roots. And what's the hint? When would we use square roots? So here's an example of an equation where we would use square roots. X squared plus 7 equals 27. What's unique about that equation as opposed to the other ones? What's that, Derek? There's no bx term, so there's no linear term. It's called a linear term, or you can say the bx term. So the reason we might use the word linear as opposed to bx is it might not have an accent, it might have another variable. But that's good. I love that. You need it to be very good. So what's a positive? What's a pro? Yeah, it can be easy. It can be fast to solve it with the square roots. But what's a con?
Not everything can be square root.
Yes. So it only works for certain equations. Okay, so now we're going to solve the next three equations. And so we have three of each, one of each type. And so we're going to figure out which which method we're going to use. So that first one, x squared plus 6x equals, or 6x plus 10 equals 0. What method would we use for that first one? You want to see if you can factor it first. So it's already in standard form. We'd look at what multiplies to 10 that adds to 6. Is there anything that multiplies to 10 that adds to 6?
No.
No. So what method would we have to use? Quadratic formula. So x squared plus 6x plus 10 is 0. What are a, b, and c? Uh-huh, good.
B is 6.
Good. And c is 10. So now we're going to put it into the quadratic formula. Yes, I will give this to you.
On the test too?
Uh-huh.
Oh, that's great. Oh, you should do that.
So we have -6 plus or minus square root 6 squared minus 4 times 1 times 10. All over 2 times 1. So I want you on your calculator. Go get a calculator. Simplify what's inside the square root. I'm going to ask somebody randomly.
I'm not mine, but you can. No.
Okay, what do we get for the number inside the square root here? Yeah, what'd you get? So So just for the number, what's the number inside? -4. So we have -6 plus or minus square root of -4 over 2. What is the square root of -4? 2i. So it's -6 plus or minus 2i over 2. What would we do next on this one? This doesn't happen every time, but on this one it does. What do we do to simplify that?
Yeah.
Is there a number that goes into all three of these?
Yeah.
Yeah, what is 2? So we're going to divide by 2. So this would be a -3, this would be I, this would be 1. So my final answer is -3 plus or minus I divided by 2.
Wait, why are you dividing by 2?
Sorry. Thank you. I was checking to see if you were listening, and you were.
Ooh, you got it. You got it.
Good. So just divide it by 1 or leave it as -3 plus or minus I. So what about the second one? 2x squared plus 2 equals -34. There's something missing there. What's missing?
The 0.
Is there a linear term in this one? No. So what method do we want to use? So not on this one. We would, since there's no x, no bx or linear term here, we would want to use square roots. See how it just has an x squared but no x. So we're going to use square roots. And when we use square roots, we want to isolate that x squared. So what would my next step be to solve this? -2. We want to get this x squared by itself. So we get 2x squared is -36. And then divide by 2. X squared is -18. And then to undo the square, square root. And so we're going to need to simplify 18.
9 and 2. 3 and 3.
So this is going to give us, since this is a negative here, it's going to give us 3i square root 2 and -3i square root 2. So the last one, x squared minus 6x minus 16. We want to see if it factors. Is there something that multiplies to -16 that adds to -6? 2 and -8. So we get x plus 2 times x minus 8 is 0. What's my next step there? Yes, so this is called, what's this property called? Zero product property, good. X minus 8 is 0, and so we get x is -2, x is 8. Okay, so there's one of each type. Okay, let's go on to the back. So we'll go to the back. We're going to start back, and then we're going to say the method. Otherwise, we go really long time.
Wait, what do you want to do?
You want me to go back up?
It's okay.
Okay. If you need me to go up after, I will. Okay, so on the first one here, what you want to do again is you want to get it in standard form so that you can see whether you can factor. So what would I do to get this in standard form? Subtract 5. N squared minus 2n minus 48 is 0. Does this factor? Is there something that multiplies to -48 that adds to -2? Yes. Therefore, we would factor on this one. So we would want to see if we can factor before we do anything. And we can. Because that will be so much simpler than the quadratic formula. So what method on number 2?
square root.
Yes. Square roots because?
There's no linear.
That's right. No linear term. No k term. No bx or bk term. So we want to use square roots. So on number 3, we want to get it in standard form. So what do? Add 7x. So this gives us so we want to see if it's factorable. 7 times -3. Some of you did that in your head. That's great. -21 and 7. Anything that works there? 2 sets of numbers that go into 21. 1 and 21 or 7 and 3. They don't work, do they? So that means we have to use the quadratic formula. But we want to try factoring first because it's so much simpler. So what about number 4? What method would we try? Try to factor what multiplies to -100 that adds to -21. A lot of numbers that go into 100. Yes, Will?
-25 and 4.
Yeah, so -25 and 4. So you would want to factor on this one. What about number 5? Square roots, because we've got a square equal to a square. So we want to use the square roots. And then number 6, what would we do first to decide? Minus 4p. We want to get it in standard form. 4p squared minus 4p minus 3 is 0. Then we want to look to see if we can factor. What multiplies to -12 that adds to -4? Does that factor? Are there 2 numbers that would work there? Yeah. So we would factor on this one. Okay.